Dear Professor and Doctor, today our topic is the interaction of corruption, pollution, and prosperity for the assignment of the course Research Methodology. Our members are Li Jinghui, who is speaking from the School of Social Science, Economics. Professor Lian Huihui is my supervisor. And Yan Ran from the School of Management, Li Hongpan from the School of Social Science, Economics. This topic is of great relevance to the sustainable development, which is the main theme of our assignment. So the presentation will be divided into 4 parts: introduction, theoretical framework, methodology, and discussion. Why this topic is important? Firstly, achieving a high rate of economic growth brings about serious environmental issues. The growing concern for environmental pollution and corruption nowadays are of great significance relevance to the process of economic development. In many countries, achieving a high rate of economic growth has become the primary or even the only goal. As a result, governing bodies such as governments, corporate entities, put aside various equally important issues, among which environmental pollution, corruption, etc. are directly related to the overall efficiency of the entire economy and the well-being of the people. Secondly, is the increasing pressure from the environmental issues. In an urgent need to deal with the global warming, economists and policymakers have paid substantial attention to the environmental-related academic topic. The most representative academic issues in this field are pollution heaven hypothesis, which has been widely studied by coal, etc., pollution terms of trade, and environmental cost net curve. To be more specific, the research of pollution heaven hypothesis aims at investigating the pattern in which pollution shifts from developed countries where environmental regulations are strict to the developing countries where the environmental laws are less stringent or non-existent. So, the intent of this dissertation is to analyze the direct effect of corruption on pollution, as well as the indirect effect, in the pathway of which corruption firstly negatively affects the income and the resultant impact affect the level of pollution. Both the direct and indirect effect are modeled in an alternative AKC model, which is designed to investigate the inverted U-shaped relationship between income and pollution. The linkage of corruption, income, and pollution are the primary focus of the investigation within this study. Based on the previous empirical framework examining the direct and indirect impact of corruption and pollution, it is the intent of this research to further understanding the dynamic relationship between corruption, prosperity, and pollution by providing a newly specified EKC framework, which is known as the BSS model, and a more superior estimating method, the GMM, which is called the General Method of Moment Dynamic Panel Data Estimator, developed by Arenalo Bond in 1991. So why this study is important? Since the goal of the dissertation is to provide policy suggestion for both well-off, middle-income, and poverty-stricken countries, this research allows for the existence of heterogeneity across countries for empirical investigation. To be more specific, this research separates the full sample containing a large panel of countries over the period of 1995 to 2014 to 4 groups, according to the threshold provided by the World Bank based on GNI per capita in 1918. in 2018, as a supplementary work to further the existing literature investigating corruption-pollution nexus. This dissertation is the first to use a newly specified EKC framework while combining the dynamic panel estimator based on a large sample to gain a deeper understanding of the relationship between corruption and pollution. The second part of the research is a theoretical framework. This dissertation highlights the theory for the explanation of the EKC as well as the corruption-pollution relationship. To begin with, the theories of composition effect, scale effect, technological effect, and demand effect, which are 16 initially proposed by Grossman and Kruger to account for the rise and fall of the phenomena of the EKC, will be presented. Additionally, this dissertation furthers the demand theory by citing the hierarchical level pyramid hypothesis postulated by Maslow. Afterwards, the intuition regarding the mechanism of which corruption impacts pollution are demonstrated. Finally, this dissertation attempts to establish a mathematical framework by which the corruption-pollution nexus is illustrated. So, this is our methodology to investigate the inverted U-shaped relationship. There are two primary methodologies: the conventional EKC model and the newly specified BSS model, to study the inverted U-shaped relationship between income and environmental pollution. Firstly, we will introduce the setup of the conventional EKC model, and then the BSS model will be presented after that. So the third part of the research is the methodology and empirical analysis. So you can see in the left-hand side of the slide is the setup of the conventional EKC model, which include the square and cubic terms of the GDP per capita to study the non-linear relationship between income and pollution. And the right-hand part of the right-hand equation is the so-called BSS model. So let's illustrate further in the next slide. So the cubic EKC specified is as follows. As we can see, the square term and the cubic term of the GDP per capita is in the equations to study the nonlinear relationship between the income and pollution. So the most concentration will be paid on the BSS model, which is demonstrated in this slide. As you can see in equation 2 and equation 3, P is the level of pollution and T refers to time measured by year. Y is the level of income in the economy, while G is the income growth rate. Both alpha and Y star are constant to be estimated, in which Y star denotes the transitional point of the EKC and alpha decides the direction of the equation. The BSS model implies that the immediate change of pollution in an economy hinge on its level of economic development and the income growth rate in a specific time. If alpha is less than 0, the specification confirms the inverted U-shaped relationship between income and pollution. The extended version equation is obtained by integrating pollution with respect to T, which yield equation 3. So the inference of this equation will be demonstrated in the following slides. As you can see, for equation 3 to equation 4, we can manipulate equation 3 to equation 4 and then equation 5. Finally, we have equation 6, where P stands for carbon dioxide emissions per capita in an economy. Y is the average value of GDP per capita in an economy, while G is the average growth rate of GDP per capita in an economy. I denotes the average degree of corruption over the sample period. Z represents a vector of controlled variables, that is, the level of education in a country, trade openness, FDI inflow, urbanization. P lag is the pollution of prior year in a country at year T. So in this part, we will introduce 3 steps: data collection, the dynamic panel data analysis, and the result analysis. Our sample data include pollution, corruption, income, and other explanatory variables such as education level of a country, trade openness, urbanization, and FDI inflow need to be obtained. The sample of the data in this dissertation contain 1,078 countries from 1995 to 2020. This dissertation separates the full sample, which is 178 countries, into 4 income groups. That is, high income group, middle income group, middle high, middle low, and low income group, according to the threshold for classification from the World Bank in 2018. The per capita carbon emissions represent a country's level of pollution is abstract from the World Development Indicator. The data on corruption is from the World Governance Indicators, while the GDP per capita is from WDI, and the rest of the control variables are all abstracted from the WDI database. So, according to the result of the model, the impact of corruption or pollution will be determined under different income groups. According to beta 0 in GAM result, the relationship between income and pollution can be verified. The result of beta 2, which measures the direct effect of corruption and pollution, while the result of beta 3 will measure the indirect effect of corruption on pollution. So, the fourth part is the discussion and conclusion. So, overall, this research used the GMM dynamic panel data analysis based on a large panel datasets including 178 countries, in combination with the newly specified EKC model to investigate the direct and indirect effect of corruption and pollution. According to the comparison of different levels of income groups, the relationship between income and pollution is inverted U-shape, which is demonstrated in the empirical results. The overall conclusion is that, according to the empirical result, the relationship between corruption and pollution will depend on the different income level. Thank you for listening.